A motherboard is the main printed circuit board found in computers and other expandable systems. It holds many of the crucial electronic components of the system, such as the central processing unit and memory, and provides connectors for other peripherals. Unlike a backplane, a motherboard contains significant subsystems such as the processor and other components. Motherboard specifically refers to a PCB with expansion capability, and as the name suggests, this board is the mother of all components attached to it, which often include sound cards, video cards, network cards, hard drives, or other forms of persistent storage. TV tuner cards, cards providing extra USB or FireWire slots, and a variety of other custom components. History: prior to the invention of the microprocessor, a digital computer consisted of multiple printed circuit boards in a card cage case with components connected by a backplane, a set of interconnected sockets. In very old designs the wires were discrete connections between card connector pins, but printed circuit boards soon became the standard practice. The central processing unit, memory and peripherals were housed on individual printed circuit boards, which were plugged into the backplate. During the late 1980s and 1990s, it became economical to move an increasing number of peripheral functions onto the motherboard. In the late 1980s, personal computer motherboards began to include single ICs capable of supporting a set of low-speed peripherals, keyboard, mouse, floppy disk drive, serial ports, and parallel ports. By the late 1990s, many personal computer motherboards supported a full range of audio, video, storage, and networking functions without the need for any expansion cards at all. Higher-end systems for 3D gaming and computer graphics typically retained only the graphics card as a separate component. The most popular computers such as the Apple II and IBM PC had published schematic diagrams and other documentation which permitted rapid reverse engineering and third-party replacement motherboards. Usually intended for building new computers compatible with the exemplars, many motherboards offered additional performance or other features and were used to upgrade the manufacturer's original equipment. Design: a motherboard provides the electrical connections by which the other components of the system communicate. Unlike a backplane, it also contains the central processing unit and hosts other subsystems and devices. A typical desktop computer has its microprocessor, main memory, and other essential components connected to the motherboard. Other components such as external storage, controllers for video display and sound, and peripheral devices may be attached to the motherboard as plug-in cards or via cables. In modern computers it is increasingly common to integrate some of these peripherals into the motherboard itself. An important component of a motherboard is the microprocessor's supporting chipset, which provides the supporting interfaces between the CPU and the various buses and external components. This chipset determines, to an extent, the features and capabilities of the motherboard. Modern motherboards include sockets in which one or more microprocessors may be installed. In the case of CPUs in BGA packages, such as the VIA C3, the CPU is directly soldered to the motherboard. Slots into which the system's main memory is to be installed, a chipset which forms an interface between the CPU's front-side bus, main memory, and peripheral buses, non-volatile memory chips containing the system's firmware or BIOS, a clock generator which produces the system clock signal to synchronize the various components, slots for expansion cards, power connectors, which receive electrical power from the computer power supply and distribute it to the CPU, chipset, main memory, and expansion cards. As of 2007, some graphics cards require more power than the motherboard can provide, and thus dedicated connectors have been introduced to attach them directly to the power supply. Most disk drives also connect to the power supply via dedicated connectors. Additionally, nearly all motherboards include logic and connectors to support commonly used input devices, such as PS/2 connectors for a mouse and keyboard. Early personal computers such as the Apple II or IBM PC included only this minimal peripheral support on the motherboard. Occasionally video interface hardware was also integrated into the motherboard. For example, on the Apple II and rarely on IBM-compatible computers such as the IBM PC Junior. Additional peripherals such as disk controllers and serial ports were provided as expansion cards. Given the high thermal design power of high-speed computer CPUs and components, modern motherboards nearly always include heat sinks and mounting points for fans to dissipate excess heat. CPU sockets. A CPU socket, central processing unit, or slot is an electrical component that attaches to a printed circuit board and is designed to house a CPU. It is a special type of integrated circuit socket designed for very high pin counts. A CPU socket provides many functions, including a physical structure to support the CPU, support for a heatsink, facilitating replacement, and most importantly, forming an electrical interface both with the CPU and the PCB. CPU sockets on the motherboard can most often be found in most desktop and server computers, particularly those based on the Intel x86 architecture. A CPU socket type and motherboard chipset must support the CPU series and speed. Integrated peripherals. With the steadily declining costs and size of integrated circuits, it is now possible to include support for many peripherals on the motherboard. By combining many functions on one PCB, a physical size and total cost of the system may be reduced. Highly integrated motherboards are thus especially popular in small form factor and budget computers. Disk controllers for a floppy disk drive, up to 2 PATA drives, and up to 6 SATA drives. Integrated graphics controller supporting 2D and 3D graphics, with VGA and TV output. Integrated sound cards supporting 8-channel audio and SPDIF output. Fast Ethernet network controller for 10/100-bit networking. USB 2.0 controller supporting up to 12 USB ports, IRDA controller for infrared data communication, temperature, voltage, and fan speed sensors that allow software to monitor the health of computer component. Peripheral card slots. A typical motherboard of 2012 will have a different number of connections depending on its standard. A standard ATX motherboard will typically have 2 or 3 PCIe 16X connection for a graphics card, 1 or 2 legacy PCI slots for various expansion cards, and 1 or 2 PCIe 1X. A standard eATX motherboard will have 2 to 4 PCI Express 16X connection for graphics cards, and a varying number of PCI and PCIe 1X slots. It can sometimes also have a PCIe 4X slot. Some motherboards have 2 or more PCIe 16X slots, to allow more than 2 monitors without special hardware, or use a special graphics technology called SLI and Crossfire. These allow 2 to 4 graphics cards to be linked together, to allow better performance in intensive graphical computing tasks, such as gaming, video editing, etc. Temperature and reliability. Motherboards are generally air-cooled with heat sinks often mounted on larger chips, such as the Northbridge, in modern motherboards. Insufficient or improper cooling can cause damage to the internal components of the computer, or cause it to crash. Passive cooling, or a single fan mounted on the power supply, was sufficient for many desktop computer CPUs until the late 1990s. Since then, most have required CPU fans mounted on their heat sinks, due to rising clock speeds and power consumption. Most motherboards have connectors for additional case fans as well. Newer motherboards have integrated temperature sensors to detect motherboard and CPU temperatures, and controllable fan connectors which the BIOS or operating system can use to regulate fan speed. Some computers use a water cooling system instead of many fans. Some small form factor computers and home theater PCs designed for quiet and energy-efficient operation boast fan-less designs. This typically requires the use of a low-power CPU, as well as careful layout of the motherboard and other components to allow for heat-sink placement. A 2003 study found that some spurious computer crashes and general reliability issues, ranging from screen image distortions to I/O read-write errors, can be attributed not to software or peripheral hardware but to aging capacitors on PC motherboards. Ultimately this was shown to be the result of a faulty electrolyte formulation, an issue termed capacitor plague. Motherboards use electrolytic capacitors to filter the DC power distributed around the board. These capacitors age at a temperature-dependent rate, as their water-based electrolytes slowly evaporate. This can lead to loss of capacitance and subsequent motherboard malfunctions due to voltage instabilities. While most capacitors are rated for 2000 hours of operation at 105 degrees Celsius, their expected design life roughly doubles for every 10 degrees Celsius below this. At 45 degrees Celsius, a lifetime of 15 years can be expected. This appears reasonable for a computer motherboard. However, many manufacturers deliver substandard capacitors, which significantly reduce life expectancy. Inadequate case cooling and elevated temperatures easily exacerbate this problem. It is possible, but time-consuming, to find and replace failed capacitors on personal computer motherboards. Air pollution and reliability. High rates of motherboard failures in China and India appear to be due to sulfurous air pollution produced by coal that's burned to generate electricity. It corrodes the core circuitry, according to the case Intel researchers. Form factor. Motherboards are produced in a variety of sizes and shapes called computer form factor, some of which are specific to individual computer manufacturers. However, the motherboards used in IBM-compatible systems are designed to fit various case sizes. As of 2007, most desktop computer motherboards use the ATX standard form factor, even those found in Macintosh and Sun computers, which have not been built from commodity components. A case's motherboard and PSU form factor must all match, though some smaller form factor motherboards of the same family will fit larger cases. For example, an ATX case will usually accommodate a micro ATX motherboard. Laptop computers generally use highly integrated, miniaturized and customized motherboards. This is one of the reasons that laptop computers are difficult to upgrade and expensive to repair. Often the failure of one laptop component requires the replacement of the entire motherboard, which is usually more expensive than a desktop motherboard due to the large number of integrated components. Bootstrapping using the BIOS. Motherboards contain some non-volatile memory to initialize the system and load some startup software, usually an operating system, from some external peripheral device. Microcomputers such as the Apple II and IBM PC used ROM chips mounted in sockets on the motherboard. At power-up, the central processor would load its program counter with the address of the boot ROM and start executing instructions from the ROM. These instructions initialized and tested the system hardware, displayed system information on the screen, performed RAM checks, and then loaded an initial program from an external or peripheral device. If none was available, then the computer would perform tasks from other memory stores or display an error message, depending on the model and design of the computer and the ROM version. For example, both the Apple II and the original IBM PC had Microsoft Cassette Basic and ROM and would start that if no program could be loaded from disk. Most modern motherboard designs use a BIOS, stored in an EEPROM chip soldered to or socketed on the motherboard, to bootstrap an operating system. Non-operating system boot programs are still supported on modern IBM PC-descended machines, but nowadays it is assumed that the boot program will be a complex operating system such as MS Windows NT or Linux. When power is first supplied to the motherboard, the BIOS firmware tests and configures memory, circuitry, and peripherals. This power-on self-test may include testing some of the following things: video adapter, cards inserted into slots, such as conventional PCI, floppy drive, temperatures, voltages, and fan speeds for hardware monitoring, CMOS used to store BIOS setup configuration, keyboard and mouse, network controller, optical drives, CD-ROM or DVD-ROM, SCSI hard drive, IDE, EIDE, or SATA hard disk, security devices, such as a fingerprint reader or the state of a latch switch to detect intrusion, USB devices, such as a memory storage device. On recent motherboards, the BIOS may also patch the central processor microcode if the BIOS detects that the installed CPU is one for which errata have been published. See also, accelerated graphics port, computer case screws, list of computer hardware manufacturers, overclocking, single board computer, switched mode power supply applications, Memory reference code, the part of the BIOS which handles memory timings on Intel motherboards, daughterboard, references. External links, motherboard form factors, Silverstone article, motherboards at DMOZ, list of motherboard manufacturers and links to BIOS updates. What is a motherboard? The making of a motherboard, ECS factory tour, the making of a motherboard, Gigabyte factory tour, front panel I/O connectivity design guide, v1.3.